Good afternoon, my dear students. So today in these sessions we are going to learn regarding the finite element analysis and finite element method. So in the last class already we studied that introductions to the finite element method for solving the field problem. So the engineering problem is broadly classified into two types. The first one is the mathematical model and second one is the experimental model. These mathematical models also broadly classified into two types. First one is analytical method, second one is numerical method. If you follow the analytical method, you will get the 100% accurate result, but this analytical method is only applicable only for the simple problem like simply support beam problem, cantilever beam problem, overhanging beam problem. But numerical method is suitable for simple problem, meanwhile it is just applicable for the complex problem we can easily solve with the help of numerical method. In the numerical methods already we have studied about the four methods. Like the first method we know very well. First method is finite element method. The finite element method is a part of numerical method. Another method is BEM, boundary element method, and third one is FVM, finite volume method, and fourth one is finite difference method. Already we studied that. This four method, it is belong to which method here? It is belong to the numerical method. So in the finite element method, it is belong to which method here? It is belong to the numerical method. The finite element analysis or finite element method, it is belong to the numerical method, or it is a mathematical representation of actual problem in our daily life. So with the help of finite element method we can solve this simple problem, meanwhile we can solve the complex problem we can solve with the help of finite element methods. Finite element method is the approximate method. So with the help of finite element methods we are not getting the 100% accurate result, we are getting the approximate result we are getting with the help of finite element method. So the finite element method the finite element method is mainly used for reduce the degree of freedom. It is mainly used for the reduce the degree of freedom from infinite to the finite with the help of discretizations. Okay, with the help of discretizations or meshings nodes and element. So first of all we are going to discuss regarding the degree of freedom. So degree of freedom, what we can say are degree of freedom? Degree of freedom nothing but the minimum number of parameter we are required. Like first thing is, for the degree of freedom we require the motion of the object. First thing is we require motion of the object. Okay dear. We require the motion of the object and we require the coordinate. The coordinate in the sense x coordinate, y coordinate we are required, as well as we require the temperature. Is it right? Then only we can use the degree of freedom. The first thing is the minimum number of parameters is required for the degree of freedom. Like we require the motion. Which type of the motions will be there? Like a translation motion or the rectilinear motion or the curvilinear motions, as well as in which coordinate the body is lies. In x coordinates lies, y coordinates lies, z coordinates lies. If the x, y or z coordinates if it is lies, then only we can use the degree of freedom. As well as temperatures is available or not, then only we can use the degree of freedom. Three parameter must and should is required to use degree of freedom. Like first is motion, second is coordinate in the sense x and y and z coordinate, as well as temperature is required. Temperature is required to define the what will be the position and state of entities complete in the space. Is it right? Let us see over here. I am taking the example of rectangular. Let us consider a rectangular lamina of a small area, what we can say A. Let us consider the small lamina, rectangular lamina of a small area A. If you want to lies, in which coordinate it lies? If you observe from the front view, it lies in the two coordinate, x coordinate or y coordinate. Is it right? So you can represent it is lies in a two coordinate only. First x coordinate or y coordinate. Okay, not here. It lies in a x coordinate or y coordinate. So how to represent the area? It is represent like this. If you observe from this center, this is x coordinate. Okay, this is x and this is y. Okay, if you observe from here. Okay, again if you observe the same body, if it is inclined, if it is the same body I am taking here, if it is inclined in a space, let us see over here. Let us consider the point A and this is point B. They are making the angle of theta. They are making the angle of theta. So they lies in the coordinate, in which coordinate they rise? They lies in the x direction. They lies in the y direction. They rotate about its own axis. So we can represent as area A is equal to, they lies in a x coordinate, comma y coordinate, comma rotation about its axis. We can represent. If you consider the cube, so cube means they can rotate in the x direction, the displacement in the x direction, displacement in the y direction, displacement in the z direction. Meanwhile, the angle about x direction, the angle about y direction, angle about z direction. So degree of freedom when we have to use, minimum parameter we are required, like the motion we are required, how the body is moving, they moving in the linear direction, they move in the curvilinear moment direction, they moving in the rotation direction. We can easily find out with the help of degree of freedom. So finite element method indicate that the finite element method reduce the degree of freedom. The main intention of the finite method is, the finite element method is mainly used for reduce the degree of freedom from infinite to finite. Infinite to finite with the help of discretizations or meshing on nodes. So what is the meaning of discretizations? So discretization nothing but, let us assume a body. Okay, this is our body. Of the total area, what we can say, area is A. So let us consider a body is divided into equal number of strips or equal number of element. Okay, the forming of nodes and element. Let us see over here. If you divide the same body element like this, horizontal, if you divide like this horizontal, this area, then in this case if you divide, discretization is nothing but, let us consider a body is divided into number of equal strips, then if number of equal strips if you divide, then you will get the more accuracy. How you will get the more accuracy? If you increase the number of element or if you increase the number of nodes, then you will get the better result or better accuracy you will get. Let us see over here. This is our rectangular lamina. Okay, if you want to measure, what will be the area? If you want to measure horizontally like this, if I am dividing the equal number of strips here like this, from at this point we will not get the accurate result. If you want to know about what is the accurate result at this position, then you need to divide number of lines. If you have divide the more number of lines, then you will get the more number of nodes. If you get the more number of nodes, then you will get the more number of accuracy, you will get the more accuracy. So for that reasons I am increasing the number of element. If number of lines or element if I increases, then due to the number of nodes also increases. If the number of elements will be increases, due to the number of nodes also increases. If the number of nodes also increases, then you will get the better result and you will get the better accuracy wherever you find the result. If you want to find out what is the positions, you can easily find out. If you divide the number of equal strip, then you will get the different element. What is the element? Already you know very well. Let us see over here. This is the first node, second node, third node, fourth node. How many nodes are there? 4 nodes. How many elements are there? It should be lesser than nodes. So let us see over here. 1, 2, 3, 4 nodes are there. Element should be E1, E2 and E3. So first of all, you have to know about what is the nodes and element. This is the first node and this is the second node. If you join in the first node, this is the first node and this is the second node. If you join in the first node to the second node, the forming of only one element. How many nodes are there here? 2 nodes. How many elements are there? Only one element. Is it right? So if you increase the number of node, meanwhile the number of element also increases. If the number of element also increases, then you will get the better result or you will get the better accuracy with the help of discretizations or with the help of meshing nodes and elements. Okay, so what is the finite element method? The finite element method is mainly used for reduce the degree of freedom from infinite to finite, with the help of discretizations or with the help of meshing nodes and element. We can easily get the accurate result. Okay, we are not getting the 100% result, we can get the approximate result we will get with the help of finite element method. So finite element method is stand for 3 words. The F is indicate that finite, E is indicate that element, M is indicate that method. The finite nothing but reduce the what is the main intention of the finite? The finite intention is reduce the degree of freedom from infinite to finite with the help of discretizations, with the help of nodes and elements. So we can say as finite. What is the element? The elements is nothing but the joining the entities from the first entities to the second entities, the forming of line we can say as element. So let us see over here. The entities joinings, nodes and forming the specific shape. Let us see over here. Here nodes is first node, second node and third node. How many nodes are there? 3 nodes. Is it right? If we join the nodes, the forming of specific element E1, E2, E3, 3 element we are forming. Is it right? The shape is, how is it here? Its shape is looking like a rectangular. If you are joining the node from the here like this is the first node and this is the second node. If you are joining the first node to the second node, the forming of line. The shape is, how is it? It's looking like a line. So the element nothing but the joining the entities from the first entities to the second entities, the forming of a specific shape such as triangle, such as quadratic, such as pentagon, such as hexagon is known as element. So method. So already we studied that they having the 3 types of method. The first method is known as analytical method, second method we can say as numerical method, third one is experimental method. So we know very well this finite element method is belong to the numerical method. Which method here? Finite element method is belong to which method here? Finite element method is belong to the numerical method. So 3 methods to solve any engineering problem. which is a three method is there. First one is analytical method. From that one we can easily solve the simple problem. For the numerical method we can solve the simple and as well as complex problem. As well as one more method is there, experimental method. We can solve the analyze on them, on the prototype model we can solve on them. So this means that they are having the three method to solve any engineering problem. The three method like analytical method already we discussed, numerical method and experimental method. This finite element method is belong to which category dear? It is belong to the numerical method. Is it right? Next one, needs of finite element analysis. What is the needs of finite element analysis? So generally we know very well the productions of any machine component related to any field of the engineering like aeronautical, mechanical, civil, electronics, in which the maximum work depend on the two departments, namely as design and production. As per as the requirement, the design engineer has to design and manufacture by the suitable method. Is it right? The design engineer, they have the lot of responsibility. When the design engineer designing any machine component, the many factor like loading. If you are designing a member, which type of the load is acting on the machine component, like tensile load is acting on the machine component, or compressive force is acting on the component, or shear force is acting on the component, or torque force is acting on the component. They have to know about the design engineer. That is the responsibility of the design engineer. As well as the design engineer, they have the responsibility as which type of the size and the shape of the component we need to manufacture. Which type of the size and the shape of the component we need to manufacture as per as the requirement of the customer. The main thing is the intention of the design engineer is to fulfill the requirement of customer. They need to satisfy to the customer. If the customer is satisfied from your product, then he will purchase your product. If the customer will purchase your product, then demand of your product goes on increases. As well as the design engineer has to know about how much quantity of the product we need to manufacture as per as the requirement of the customer. The first thing is the designing a component, the many factor like we have to know about the loading, which type of the load is acting on the machine component. Tensile load is acting, compressive load is acting, shear force is acting, torsional force is acting, or bending load is acting. Which load is acting on the machine component has to know about the design engineer. And what are the size and the shape of the component we need to manufacture, and how much quality we need to produce as per as the requirement of the customer. After the designing is completed, we need to analyze by the design engineer. The design engineer dealing the types of loading and the resulting parameter like which type of the nature of the stress is acting on the component, like tensile stress is acting, or compressive stress is acting, or shear force is acting. And if the stress is tensile load is acting, it causes how much displacement is occurring. He has to know. And the design engineer has to know about if the shaft or any component, if the rotating, it will produce the vibrations or not. If the produce the vibration, it should be affected to the human being. So they have to analyze each and every parameter like the nature of the stresses, like strain, like displacement, like vibration, they have to observe carefully, who analyze by the design engineer. And also operating and surrounding temperature parameter like heat transfer, what will be the temperature distributions may also be analyzed with the help of ANSYS software. We can analyze on them. So if the type of loading are simpler, the analyze method will be easy for the entire component. Is it right? The solutions can be determined in one or two operations. At the same time, if the surrounding and other things are complicated, if the types of loading is simpler, the analyze method will be very easy for the entire component. So we can solve in one or two operations. But if the problems are complicated, then solutions also complicated. Then if the solutions will be complicated, then we need to follow the finite element method. If you follow the finite element method, then we can easily solve the problem. If you adopt finite element analysis can be adopted, in which the whole body system we need to divide into small element whose characteristics are studied. So already we told that the finite element analysis can be adopted. In such situations, we need to divide the whole body into the small element, then you will get the accurate result. If the number of element or number of nodes will be increases, at that time you will get the better accuracy, better result you will get with the help of finite element analysis. Okay, so next sessions, if you have the doubt regarding this problem, regarding this class, please write down in the comment box, and please like and subscribe my video. Don't forget to subscribe my video here. In the next sessions, we are going to discuss regarding the applications of finite element method. Thank you for watching my videos.